Hello everyone, welcome to the Google Cloud Platform tutorial. And today is part 2. In part 1, we already covered all the basics. We understood what is cloud, we understood what is GCP, and we also set up our GCP account. In this session, we're going to look into something very integral and important, that is compute services in GCP. And before we move on and understand those in detail, make sure to subscribe to Scale's YouTube channel and hit the bell icon so that you don't miss out on this series or any other upcoming videos from us. Now, also, if you want to learn some technologies and frameworks from industry experts, the link is in the description below. We conduct free masterclasses. So now let's look at the topics that will be covered today. So as I said, we'll be looking into compute services. First of all, we'll understand what are compute services, and we'll look into certain compute services which are really important in GCP. Once that is done, we'll be covering this main service called Google Compute Engine or GCE, and that is the service which we'll be covering extensively today. We'll be looking into the basics of it. We'll look into storage. We'll look into its connectivity. We'll look into how to create them. We'll also look into certain demos in them. So that we'll do at the end. We'll be looking into creating the virtual machine in GCE. Once we create a virtual machine, we'll create an image of the GCE. We'll host a simple web page as well on that particular virtual machine. So that's basically it. Now let's get started. So starting off with understanding GCP compute services. First of all, let's understand what are compute services. Moving further, we'll get to know it even better. So in the last session, I took you through all of these various services available, right? I took you through compute services, storage services, databases, and there are so many more categories or platforms of services available in GCP. Similarly, there is one main category which is called compute services, and to put it simply, it's used for computing. Anything that is computing can be done using compute services. For example, what exactly is computing? This laptop which I'm using right now can be used for computing. I can do a simple mathematical calculation or I can run a software on top of it. Similarly, using these compute services, you can do the same on the cloud. So you can use any kind of processing. For example, let's say you have a really simple Python program to run. So you can launch a very simple server on the Google Cloud, and over there you can copy the code, you can install the Python software, and you can install other dependencies, and you can just run the Python code over there. Similarly, let's say you want to perform a high computing task, like basically let's say you want to perform a task that will require a lot of computing power, and that will require a lot of CPU. In that case, again, you can pull up, or you can basically create a virtual machine that uses enough CPU, enough RAM in order to run that, right? So you can do all types of computing on top of it. There are various services that help you do that, and computing is basically just CPUs and RAM, basically a server or basically a computer, but you get to do it on the cloud. That's basically it. And it provides a range of services. For example, over here, let's talk about a couple services. So there is Compute Engine, there is Migrate to Virtual Machines, there is Cloud Run, and there is App Engine. Okay, so let's look at them one by one. First of all, Compute Engine. So Compute Engine actually is the most integral service in GCP. For that matter, let's say in any cloud platform, AWS or Azure, the virtual machine service is the most integral service in the entire ecosystem. Similarly, in GCP, Compute Engine is the most used or the most vital service, because without Compute Engine, you can't run anything else, because without computing power, nothing else can run. For example, let's say you are able to develop a really good machine learning model, but to run it on the cloud, you would need compute power. Without this compute power or without these computing services, you can't do that. Okay, so now high performance and general purpose virtual machines that integrate easily with other Google Cloud services and scale globally. What are all the things you can do using Compute Engine? Uh, LOB enterprise apps, web hosting, databases, most workloads. To be honest, you can literally do anything you can do with a computer. Like, let's say in this laptop, I can create this laptop into a server and host my web page or website on this. I'll just have to install a web server. I'll have to register a domain for my IP, and then it'll be good to go. Similarly, I can do that same with Compute Engine with much less work. I don't have to define anything. I just have to choose the operating system. I just have to choose the configuration, that is how much CPUs or cores I want and how much RAM I need. And then rest of the details will automatically be available over there. You create it, Then let's say you can host a web page, you can run a complete website, you can run a database server on it, you can run a machine learning model on top of it. That totally depends on you, because it's exactly the same as your computer. Whatever you can do on your computer, you can do it on Compute Engine. Now, later in the session, the final part of the session, I'll be showing you how to create a virtual machine and also how to create a simple website and run on top of it. That we'll see for later. And if you want to watch exactly that demo part, you can go ahead. Or if you want to learn theory, please continue. Now, this is Compute Engine. Next comes migrate to virtual machines. So migrating to virtual machines is that this is more helpful for a person who's working in a company who already has legacy systems. So for example, if you're an individual contributor, if you're a person who is trying GCP or any cloud for the matter for the first time, then you wouldn't have any virtual machines in your local system or in your company system to migrate to the cloud. But let's say you're working for a company and you're learning GCP, migration tools are one of the most important tools, because the company might already have their databases or their websites are running on a physical server in their own data center. So now you'll have to migrate it onto the cloud for the cost benefits and other things that cloud provides, that is scalability, flexibility, and more, right? To do that, you have services already available in GCP. So there is a migration tool. You can use the migration tool and you can directly migrate applications from your local physical data center directly into the cloud data center, that is Google Cloud, right? That's basically it. uh, Frictionless migration, provisioning and right sizing, on-premises stateful rollback. So basically, let's say there is a fault on your cloud. When you migrate, you can roll back to your on-premises system, nothing will be changed. There won't be any downtime because this will be a synchronous process. So now frictionless migration is basically that there would be some sort of downtime, so your application might get slower for a few like hours or few minutes according to the size of your virtual machine or application which is getting copied over. But there won't be any downtime. Your application will be always available, always running. There might be a small change in performance. That's it. So I think that could be managed if you are completely migrating an application from one data center to uh, let's say cloud. But again, this could be managed in different ways. You can your application can still be running in other regions and zones, and you can migrate just in one single cloud, right? These two are done: Compute Engine and migrate to virtual machines. Next, there are two platform as a service. So Compute Engine is infrastructure as a service. Why? Because they are providing you infrastructure in the sense you get to choose what operating system runs, you get to choose the RAM, you get to choose the network. You are given access to the complete server over here, and you can make any kinds of changes. You can install any kind of software in it. You have OS level permissions. But that is not the same in platform as a service. For example, you also would have used software as a service. For example, let's say you're using Gmail. You are able to create a email, you are able to send the email, and you are able to receive emails. So all of this is happening because of code stored somewhere. But you don't get access to that code. You get access to the software that is running on top of that code. So that is called software as a service. You are getting software over the internet as a service. Similarly, there are some things called platform as a service. In this case, you get a platform as a service rather than a software itself. So what exactly is a platform? Platform is where you get to do certain things. It will be completely managed by Google Cloud Platform in this case. For example, let's talk about App Engine. So what exactly App Engine does is it provides you a platform, a serverless platform to be exact. Serverless is theoretical. Technically, there would be servers running in the backend, but you won't be provisioning them. You won't be creating those servers by yourself, and that is why it's called serverless. You should, or you will concentrate on the application's code itself. And once you create the application's code, you would upload it to this platform, like let's say App Engine. Let's say your code is PHP or Python. You will select the right platform on App Engine, upload your code. App Engine will take care of all the other things. It will provision your servers, it will provision your database servers, it will provision storage, it will provision whatever. Let's say you also want a container, you want to use Kubernetes engine, you want to use Docker, whatever it is, it will automatically do it for you, and it is also highly scalable. That basically means, let's say your application currently has 100 users, and it creates a simple architecture to handle those 100 users. Let's say your application becomes an overnight success and there are suddenly 10,000 users using your platform. Now, using App Engine, you can scale up your service very easily. You can go up to 10 to 100 servers, or 100 to 1000 servers, or even scale down 1000 to 50 servers easily, and it won't affect your application's performance at all. Next, coming to Cloud Run. So App Engine is a fully managed serverless platform. Similarly, Cloud Run is also a fully managed service, but this is for containerized applications. For example, containerized applications are running on Docker, and for example, you can see in this case Cloud Run for Anthos. So there are certain services, or you can create or you can run various microservices on top of it. And you can see Cloud Run can be used for web services, data processing, automation, and App Engine can be used for modern web applications, scalable mobile backends, and automatic scaling. So these are platform as a service. Again, to distinguish between platform as a service and infrastructure as a service, I'll give you a simple example. In Compute Engine, which is an infrastructure as a service, you get OS level permissions. You get to install software directly within the server. But here in App Engine, you don't get to do that. You select the languages and tools which you require and add it as a script, or you automatically select the platform in App Engine itself and they provision it for you. You don't get OS level permissions. You just get permissions to scale the architecture or scale down the architecture, and you basically get overall permission rather than given permission to every single server which are created basically in App Engine, right? So if you create an entire architecture by yourself, you have access to every single resource individually. But that won't be the case here. You will only have access to the platform on top of which you created this entire architecture. So hope that is clear. Okay, so these are compute services. Um, so we understood what are compute services. We understood a few compute services which are available. There are still more compute services in Google Cloud. We saw that in that cheat sheet. There are 10 more compute services to go. But again, as I already told you, you don't have to know every single service in cloud in order to become a master of something. You just have to learn the services which are required for you. Let's say you're an administrator, you will just have to learn the services that will help you administer the cloud. If you're a developer, you will just have to learn the services that help you become a better developer and develop applications that can run on the cloud. For example, you should learn Cloud SDK. You will have to learn the software development kit so you can make the applications you're building cloud friendly so that you can directly run it on cloud, right? So that's basically it. In the next topic, we'll be looking into GCE in particular. What is Google Compute Engine? So let's get started with that now. Okay, so what is GCE? Compute Engine is a computing and hosting service that lets you create and run virtual machines on Google infrastructure. So now, on your local system, you can create and run virtual machines. If you do not know what virtual machines are, it's pretty simple. Let me give you a simple example. Let's say this laptop runs the Mac OS on it. So now, let's say you have a software that can only run on Windows. So I can't run that on the Mac OS, right? So now what I can do is I can install a virtual machine software and I can run Windows on top of this operating system and install the software in that Windows virtual machine, which is isolated from the Mac operating system. Basically, it's isolated. That basically means it doesn't interfere with the processes of the Mac operating system, right? So now that's basically it. And let's say you have a Windows PC and you want to run Linux commands or you want to run a Linux application. In that case, you can create a virtual machine of a Linux system, let's say Ubuntu or Red Hat, and on top of that, you can run those Linux applications. So virtual machines are something which is isolated from the current hardware. So in one hardware, you can have hundreds of thousands of virtual machines. Let's say if this laptop can let me run thousands of virtual machines, each of those virtual machines will be individual computers. Like you can assume them as individual computers, even though they are virtual, right? They are not, so these virtual machines don't have individual hardware. They are running on top of the same hardware, but they are isolated from each other. So they are individual isolated virtual machines. So the same thing we can do it on Compute Engine as well. On GCP, you can create your own virtual machines by providing your details, and they will create a virtual machine in Google's infrastructure, and they will give you the details to log in into that particular server and use it. So practically, you are renting Google's infrastructure. We are not exactly creating a new thing, or buying a hardware, or we are not setting up something completely. It's already over there. Google has already set everything up. You're just providing the name, you're choosing the operating system, you're choosing the core, you're choosing the RAM, and then it creates it for you and gives it to you. Now, Compute Engine offers scale, performance, and value that lets you easily launch large compute clusters on Google's infrastructure. Compute clusters are basically a group of virtual machines. For example, let's say as an individual user, like for me, I don't have to create thousands of virtual machines at the same time. I don't have to create thousands of virtual machines so that I can run my website smoothly. For me, the main concern would be to just create a couple of servers, a couple of virtual machines to run my websites or create a sample project. Or let's say if I have a startup, I would need, let's say, 20 servers or 30 servers. I wouldn't need thousands of servers. But if you're working for a company who requires a complete compute cluster, you can still do that. Let's say you can create 1,000 servers in one single go. You can just provide the number as 1,000 while you're creating servers, and it'll create 1,000 servers of similar capabilities. So Compute Engine offers scale, performance, and value that lets you easily launch large compute clusters on Google's infrastructure. So to be talking about clusters, it doesn't have to be a deal for us, like for an individual user. It is important for a person who's working in a company and trying to implement cloud into their servers architectures. For example, let's say you have an application that thousands of people or millions of people are using. Then in that case, obviously you need a cluster of servers. That is a group of virtual machines in this case, right? But for an individual user, you will create a couple or maybe five servers, and you can do that individually. You don't have to even create a cluster for it. You can create these servers individually. But a cluster, what exactly is a cluster is that you can form a virtual machine cluster. They all of those servers which will get launched within that cluster will have similar features and similar specifications. Like let's say if 10 GB of RAM, all of those servers will have 10 GB of RAM. And you can increase the number of servers or virtual machines within the cluster, or you can decrease it according to your application's demand. That's basically it. And one more uh, reason is that there are no upfront costs, there are no upfront investments. You can run thousands of virtual machines on a system that's basically far quicker and has consistent performance. So why exactly we are talking about upfront costs is that, let's say if you have an application and you want to set it up, then to get a physical data center, that is getting a place, renting it, the rental cost, then the upfront cost of buying the hardware and setting it up, the security and networking professional you need to handle all those hardware, and also setting it up with the help of developers in your system. And that will be a huge hassle because that will involve a lot of upfront costs. This could be for big companies. For example, let's say the Google service, right? YouTube, Gmail, all of that runs on top of GCP. And Google Cloud Platform is Google's own data center. Even though they offer it as a cloud, they still have that data center. It's still their own physical data center. So they'll have to maintain it and manage it. But for us, it's a cloud. We can rent these servers from GCP or any other cloud platform for that matter. So these are the reasons why GCE is used. And this is basically what GCE is. It's to create a virtual machine on cloud, right? Now, let's look at the basics of GCE. The most basic component of GCE is an instance. So from here on, I'm going to call these virtual machines or servers as instances. One instance is one single virtual machine, right? So an instance is something that can run the public images for Linux and Windows Server, that provides as well as private custom images that you can create or import from your existing systems. To put it very simply, Linux is open source, right? So you can get those public images for them. Public images in the sense these are installation files. You can consider it as installation files. So these images are already available in GCP. While you're creating an GCE instance, you can choose that you want to create a Linux instance. You can choose that you want to create a Windows instance, and accordingly, it will take the image. For example, if you want to install a Windows instance, it will take the Windows image. If you want to install a Linux instance, it will take the Linux image, and then it will create this instance and give you the details back to you. Instead, if you already have a local image, or if you already have created an image by yourself, let's say you don't want a Linux system, or you don't want a Windows system, specific Linux operating system, let's say you want SUSE Linux, and you already have a system set up for it. So now you can create a image of that. An image is basically a copy of that virtual machine, and that copy can be used, that custom image can be used to create an instance. So instance is the basic building block of GCE. And by default, every single compute engine instance has a small boot persistent disk that contains the operating system. For example, this laptop is useless without its storage, because without storage, the operating system can't run, because the operating system files will not be stored anywhere. And without storage, you can't run any processes, you can't basically do anything in the laptop. Even though you have every single hardware, without storage, there is nothing possible. Similarly, while you're creating a Google Compute Engine instance, when you're creating this single instance, every instance will get connected, or will also create a small disk connected with it. So without the disk, you can't do anything, because the disk will have all the operating system files installed in it, right? So that is also important. Next comes the network interface. So first, an instance is the virtual machine itself. The virtual machine will have a storage attached to it. Without the storage, you can't run the operating system. And finally, there is something called a network interface. A network interface is basically attached, or is a subnet of a unique VPC network. A VPC is called Virtual Private Cloud. It's a separate service in GCP that we'll look into in later part of this particular series. But when you're talking about a network interface, when you're creating an instance, the instance will be associated with an IP address. Every single machine in the world is associated with an IP address. Similarly, the virtual machine will also have its own IP address. So there are two types of IP addresses. One is the private IP address, which is eligible within the network, and there is a public IP address, which is eligible over the internet. Let's say it is connected in LAN to another laptop. So this laptop will have a private IP, and that will have a private IP. And this laptop can recognize the other laptop through the LAN cable, because they are connected in a simple private environment. But if I want to connect to the internet with this laptop, I will have to connect to the Wi-Fi, or I'll have to connect to a broadband network. And when I connect to a Wi-Fi or a broadband network, I would need a public IP address to put my laptop out there. So when I put my public IP address out there, I'm able to get those details over the internet. For example, internet is just a bunch of computers sharing files with each other. Similarly, if I want to watch a video, I'm just getting files from a computer or a cloud stored somewhere. For example, you're watching a video on YouTube. When you click on a video, it gets the data from Google's CloudFront, sorry, not CloudFront, in Google CDN, Content Delivery Networks, and it gives it back to you. And that's basically how you're watching a video. Similarly, in this case, you would have these IP addresses attached to your virtual machine, and without these IP addresses, your virtual machines have no meaning. An IP address is basically what defines the system itself, right? So while you are creating the demo, it'll be even more understandable. And then finally, an instance group is a collection of virtual machine instances that you can call manage as a single entity. For example, let's say you have an application that requires 10 or 20 servers of similar kind. Then you can have all of these 20 servers and run it. And these 20 servers will basically be running within a group. And let's say you want to delete all of these 20 servers at one go. You can delete the instance group, and that will automatically delete all of these servers. It's an easier way to manage, but again, as an individual, you might not create 20 servers, but if you do create, it's a better way of doing through an instance group, or it's another way of doing it through a clusters. right? So these are the basics of GC. There are still a lot more basics, but again, if we cover all of the basics, that will be the entire documentation. I would suggest you to go through the documentation once if you are not understanding a particular concept. Again, if you're not at all understanding those concepts, leave it in the comment section of this video. I will help you with that, right? So next comes the mission resource guide. So what exactly is a mission resource? It's basically the instance type. For example, uh, as I told you, there could be different types of instances. You can have a simple instance which just has a web page running on top of it. You can have an instance that is running a database server on top of it. There could be an instance that's running a complete, let's say, ERP tool on top of it. There could be a system, for example, it could run a gaming servers. It could be a game servers that has a lot of traffic coming in. So there are different types of virtual machines which you can create. You can create the most simplest virtual machine or an instance. Similarly, you can create the most high-end instance in GCP itself. It is just a matter of choosing what type of an instance you want. And looking over here, you can see we've segregated it as two types, which is general purpose workloads and optimized workloads. Let's look into the general purpose ones first. Under general purpose itself, there are cost optimized, balanced, and scale out optimized. Right. So now looking at E2, which is the cost optimized type of machines. So day-to-day computing at a lower cost. For example, if you want a server or something on demand, then E2 is the right machine type to go ahead with, because it's basically general purpose workload. You can run any kind of an operation on top of it. You can run a web serving application, an app serving application, back office applications, basically private applications within your organization, small medium databases, microservices, virtual desktops, development environments. So E2 is used for that, and E2 micro is basically the free tier eligible uh, instance type or mission, right? And similarly, under balanced, there is N2, there is N2D, and N1. Balanced priced slash performance across a wide range of machine types. This is also used for similar types, but here in this case, you can run medium to large databases. You can also use it for cache and media slash streaming applications. And then scale out optimize, there is tau T2D, tau T2A. This is for performance slash cost for scale out workloads. So scale out workloads are basically for applications that have varying traffic. Let's say you have a food delivery application, and people usually buy food from the morning till like late night. There would be some orders happening in between, let's say 12 a.m. to 5 a.m., but that will be very, very minimal compared to the orders which happens throughout the day, right? So for that, you would need a scale out workload. You would need more servers during the day and fewer servers in the night to make it more cost optimized. So that's exactly what scale out optimized workloads are. They basically try to reduce your cost by scaling out or scaling down your servers according to the incoming traffic. According to your requirement and performance, they automatically increase or decrease the number of servers. That's basically it. And it can also be used for other stuff. There is containerized microservices, media transcoding, large scale Java applications, not necessarily Java, any applications. This is just one example. Next, over here you can see there are again three types of applications, but these are optimized workloads. Optimized workloads are specifically for one particular category. There is memory optimized, there is compute optimized, and there is accelerator optimized. Memory optimized applications are for high memory workloads. High memory workloads in the sense for applications that have to run processes in memory itself. For example, memory large OLAP and in-memory databases such as SAP HANA. So OLAP is basically online analytical processing, right? In this case, what exactly is online analytical processing? You are able to run analysis in real time. You're pulling real time data and running analysis online, and then maybe push it into another database where you can do more analysis, right? So all of this will happen in memory itself. Not even don't get stored, they happen in memory itself. For that you need high memory workloads, because for high memory workloads you would need a memory optimized instance. That's basically it. in-memory databases and in-memory analytics, Microsoft SQL Server and similar databases, genomic modeling, electronic design automation. There are more things which are requiring memory optimized. You don't have to worry about them. Those are more advanced topics. To keep it to a very basic level, all kinds of in-memory databases, in-memory analytics, for example, caching databases can use memory optimized uh, instance type, right? In compute optimized, these are for uh, ultra high performance for compute intensive workloads. So compute intensive workloads are basically workloads which have a lot of processing and transactions happening. For example, let's say a banking server. A banking server keeps running all the time because transactions keep happening, payments keep happening, and to keep them working or running, you would need compute intensive workload. So similarly, for example, gaming, online gaming or multiplayer gaming online is also a very compute intensive application, right? For that, again, for gaming, ad serving, media transcoding, to run AI and ML models, to run high performance web serving. For example, you want your website to be right there when somebody enters your URL. You don't want to waste any time. So if your website has to be that quick, you need to have a high performance web serving instance. So for that, you can use a computer optimized instance. And finally, accelerator optimized. So in this case, it's optimized for high performance computing workloads. This is compute intensive. Compute optimized are even a higher category. Accelerator optimized are a bit of both memory and compute. So in this case, you can see HPC, that is high performance computing, massive parallelized computation, that is if there are multiple processes running at the same time, you can go ahead with this. And for CUDA enabled ML training and inference. And for ML training and testing models, you can again go ahead with this. But again, as an individual, the most uh, common and the most easiest workload type you can go for is E2, because that is day-to-day computing. And so this website link is provided here. So let me just open that quickly. So general purpose is for best price performance ratio for variety of workloads. Compute optimized for high performance per core compute engine on compute engine and optimized for compute intensive workloads. Memory optimized for more memory per core than other families. For example, let's say you have 10 cores, you can have uh, let's say 300 GB of RAM. But you can also have 10 cores and 24 GB of RAM. That's one type of a mission. But you can have the same 10 cores but have 300 GB of RAM. So that increases the memory. So that would become a memory optimized instance, right? An accelerator optimized is basically used for massively parallelized compute unified device architecture. It's basically for testing ML models and high performance computing, right? Okay, so now you can go ahead and learn more about this, learn more about the types, learn more about the intricacies of everything. So for example, let's take N1 over here. You can see what are the different types of CPU available over here, what architecture it is. Most of the architectures are x86 only. And then how many CPUs can it handle? For example, N1 can range from 1 to 96 CPUs. It's threaded, it's not a core. This is the virtual CPU. There are also core CPUs, and memory can be from 1.8 gigabytes to 624 gigabytes. In this case, you can see M2 is memory optimized, or M3 is also memory optimized. So in this case, memory, that is memory is very, very high compared to the cores, the CPUs, right? And if you talk about cost optimized, these are very cheap. E2 is the most cheapest uh, mission type. E2 also comes under free tier. If you use E2, it's actually free for basically forever. And then, yeah, one more thing is accelerator optimized over here. You can see it has a decent amount of uh, memory and also cores. Yeah, so it totally depends on what type of an instance you're going ahead with. So this is decent RAM to really high cores, compute optimized. These are decent cores to very, very high RAM, right? But these instances are very expensive, so make sure you don't spin them up and leave it. If you just leave it, it will keep running and the bills will get generated and it'll be a really high amount. So make sure you don't. For practice, always go ahead with E2 instances. Any kind of E2 instance is fine, but E2.micro is preferable because it's free. Okay, so rest everything you can look into this. You can look at more details. So I don't want to get into more details because that will again stretch the length of the session. Okay, this is done. Moving ahead. Now, regions and zones. Before we move on with the demo, which is the next part of the session, this is one of the most important concepts to learn. So you already learned the basics. That is, what is an instance? You learned a network interface is attached to it. You already learned every virtual machine is isolated from the other virtual machine. But again, there is something called regions and zones. So in the previous session, I showed you the global infrastructure of GCP. So when I showed that, you would have understood, okay, they have these many data centers across the globe. But these data centers have their own zones within them. For example, let's say compute engine resources are hosted in multiple locations worldwide. These locations are composed of regions and zones. A region is a specific geographical location where you can host your resources. Regions have three or more zones. To put it very simply, let's say there is a data center location or there is a region, Google GCP region as Mumbai. There are there is a Mumbai region and Delhi region in India. Let's consider Mumbai region. So in Mumbai, there would be multiple zones. Zones are individual data centers. For example, in this case, US Western region denotes a region on the west coast of the United States. But in that region itself, in that geographical location, there are three different data centers located. There is a US West 1A, there is 1B, and 1C. It can have more zones as well. That depends on the geographical location and Google themselves. If they have invested and have created more zones over there, there would be more zones. So why exactly do you have zones? For example, let's say your application has to just be targeted towards the Mumbai crowd. Let's say your application is very popular in Mumbai and you want to run your application just in Mumbai. In that case, you can run your application in Mumbai, but to make it highly available, to make sure your application doesn't fail at all, there will be multiple zones. Your application will be running in all of these different zones. Let's say due to some power outage, one zone goes down. The other two zones will still keep running, and that will keep the application afloat, and the application will not have any downtime. So this is why zones and regions are really important. It's basically like a three-phase power line. Even if one phase goes, your internet will still be up. Only some parts of the functionalities won't work. Now, why exactly zones? One, I said handling failures. So distribute your resources across multiple zones. So if one zone has an outage, the other zones will still be running your application in it. So Google designed zones to minimize the risk of correlated failures caused by physical infrastructure outages like power, cooling, or networking. So they design it as such, if one zone goes out due to a power outage, the other zone would not be anywhere close to it. It'll be a little further away from it so that that area does not experience the same power outage, right? Decrease network latency. So this depends on you. So let's say you want to create an application catering to a particular crowd. Let's say you want to run the application in for a Bangalore crowd. So in Bangalore, you will have to basically make sure you run your application in a server which is very close geographically to Bengaluru. That will make the application run even faster because the network connectivity will reduce and the latency also will decrease. Even here, they've provided an example. For example, if you have mostly customers on the east coast of the US, then you might want to choose a primary region and zone that is close to that area and a backup region and zone that is close by. For example, let me take another example. In this case, let's consider India. Let's say your application's main base is in Mumbai. Now, your main region and zones would be in Mumbai, but you'll also have to have another region so that if the entire region goes under some power outage, your application will still be running in another region, and that region could be Delhi. That's basically what they are talking about here. If your application is running in the same geographical region as the customer base, that will decrease the latency. So that's basically it for regions and zones. In the next part of the session, I'm going to take you through the Google Compute Engine demo. So in this case, there are three things which we'll be looking at. One is I'll be showing you how to create a virtual machine, and then I'll show you how you can host a simple web page on top of it, and how to create an image of the VM. So before doing all of this, I'll just take you through the console quickly. I will just show you what are the things that are available on the console, because in the last session, I hope you guys have already set up your GCP account. So I will take you through the basics in the console. What are the things you'll have to look at? What are the things you'll have to set up first? So if you already created an account and logged into it, it would have created something called your project. So your project is basically a set of resources. So all of the resources you create will come under that particular project. You can create multiple projects, but for now I have one single project created. I'll take you through that, and I'll also take you through all the other elements within GCP. So now let's get started with the demo. I've already opened the console over here, so make sure you also open the console right with me. Okay, so open the Google Cloud console. You already created the account. If you did not create the account, just watch the previous video. I've showed you how exactly you can start creating the account, and you will just have to provide your payment details and it will automatically get created for you. And you will get a free tier eligibility for 3 months. So make sure you do that as well. So once you create your account, the first thing you will get is your project. So this first project will automatically get created. You can later create a new project over here by just clicking it, providing your project name and choosing the organization. If it does not come under any organization, if it comes under your own billing account, then you'll go ahead with that. And then you will select the folder under your organization, select it, that's it. Simple as that. A project is basically a repository. Like in GitHub, you have a repository, and under the repository, you have all the files, all the code files, the README, everything is available, right? So it's basically like one big folder. Within this, you can create any number of resources. You can create any kind of architecture. You can run any kind of applications over here. So now this is the main page. You can see you're working on my first project under this particular uh, domain, and a project ID, project number, everything is given. So now the first thing you can check is actually the dashboard. By clicking on dashboard, you can see all of the projects, all of the services that are running right now. There are literally no services because this is fresh account. uh, you can see APIs, nothing is there. There is one project available here, resources, getting started guides over here, news, documentation, billing. Yeah, so basically everything is in this one single dashboard. You can just look at this, and if you can add more widgets over here by just clicking on customize. If you don't want a particular thing, if you want a compute engine chart as well, you can add that. If you want a SQL chart as well, you can add that. So if you don't want anything else, you can just click on done, right? So this is your own customizable dashboard. Then activity, you can see what has happened till now. I've already created a simple, you can see over here, these are some of the activities which are happening in this AWS account once it got created. So first of all, they automatically set up certain things for you. You can see a project got created, certain Google services by itself started running, set IAM policy on project, you're creating VM, set metadata, creating an object, create a firewall rule, delete a virtual machine. Yeah, so basically every single activity that happens within your project can be tracked from the activity sheet. Next, recommendations are basically recommendations provided by Google themselves to you. For example, currently I'm not running any application. For example, let's say you have an architecture already running on Google. They will let you know about recommendations on how you can optimize your architecture. Let's say your architecture lacks in security in one particular place. They will give you a recommendation on how exactly you can make it even stronger, or how exactly you can cost optimize it, or how exactly you can improve the performance of your application. So this will be provided. Again, you don't necessarily have to take them up and make these changes. These are just improved recommendations. If you think something else is better, then you can totally go ahead for that. Okay, so that's basically it. That's the dashboard and overall console. Next, at the top, you have the search bar. You know what a search bar is for. You can search for services, you can search for documentation, other products, and everything. And then there is something called the Cloud Shell. I have not activated the Cloud Shell. A Cloud Shell is basically like a terminal over the cloud. Like how in this MacBook, I can open my terminal. Similarly, I can open the Cloud Shell on Google Cloud. So opening the Cloud Shell, I can run commands and access my Google Cloud services directly from the shell itself. right? And then this is notifications, this is support. If you want to increase the quota of some particular service within your GCP account, you can send that to support. If you have any problem with that, then again everything comes under support. Then settings and utilities, these are again project settings, preferences, uh, and downloads, cloud partners. These are just things which are necessary within the website. This is not exactly for you. You don't have to go ahead and check it. But again, if you have any other things to change, you can go to preferences and change your own settings. And then this is just my account. Yeah, so that is done. This is basically the dashboard. Now, moving further, the first thing we are going to do is create a virtual machine. So to create a virtual machine, we are going to use compute engine, right? So now before moving on with that, let me quickly just give you an overview of app engine, because this is one more service we learned about, right? You can see uh, app engine. You can create an application, a simple application app engine over here. You can see over the left side, dashboard, services, versions, instances, cron jobs, security scans, firewall rules. For example, the dashboard will have all of these things over here once you create the application. And then services will have what are the different services you're using within App Engine. Let's say if you're using Compute Engine, you're using storage, you're using SQL database, you're using basically Cloud SQL, or if you're using an AI ML tool, all of those services will show up under this section. Versions are newer versions of the application. Let's say you are creating an application and you're making a code change and you're uploading a newer version. So the older version will still be stored in the App Engine environment itself. If you want to revert back to the older version, you can still do it. And then instances are basically the compute engine instances which are running under app engine. As I told you, this is a platform. Underneath the platform, there would be servers running, but you wouldn't provision them. That is, you wouldn't create them directly. You would just give instructions. Google Cloud will create it for you. Task queues. So this is basically for different tasks happening in a particular order. And then cron jobs are basically, for example, let's say at 5 o'clock in the night, let's say not in the night, 5 a.m., you want to run a maintenance check for your application every single day. Then you can set up a cron job which exactly does that. Every single day, 5 a.m., you need to run a maintenance check. You can write a script, and that script will get executed every day at 5 a.m. if you set up the cron job accordingly. So that's basically it, and these are more information. So to create an application, it's very, very simple. Click on create application. Select in which region you want to host your application. So they've given a map as well. For example, you're in India, you can choose the Mumbai region, Asia South one. If you don't want to choose the Mumbai region, you can choose the Australian region, you can choose the US region. So one more thing is that most of the new products and most of the new updates happen in the US region. So if you want to use the latest features, if you want to use the latest products, then it's better to go ahead with the United States regions. For example, this is uh, one such region, US East 1, this is US West 2, this is US West 1. So you can basically select the region which you need, or if you are confused, you can just let you can just let it be the first region it automatically selects, right? US Central. um, and then identity and API access. Right now it's a new account, so you will have to create one, or you can just choose one which is already available there, and then you can choose a default service account. So IAM is basically identity and access management. So without access, you can't access a particular service. So similarly, you will have to create users in order to access certain services. For example, let's say I have this account and there are two more users who want to access this account. It is not secure to give the root account credentials to them. Instead, you can go to IAM, you can create two users and you can share those user details with them, and they can log in to the system as a user. So I hope that is clear. So now it's creating the application, now it's configuring the application. Now this is the main part, because you can choose the platform. That is, you can choose the language in which you want to run. If you have a Python application, you can select Python. If you have a Node.js application, go in Node.js. Similarly, if it is within any of these languages, you can automatically select. If it is not within these languages, then you can select other, and you can basically link the GitHub account directly over here, the GitHub repository, right? Let's say I choose Python. Environment, standard or flexible. Standard environment would be the basic servers, there would be one server, one database, stuff like that. But if it's flexible, it will automatically increase or decrease according to your website's thing. So here you can do this later as well. And now your thing is already created. You can choose your resources, and you can, once this is done, once your cloud SDK is also downloaded, then you can basically connect your GitHub, and then it'll automatically start running. See, now your application has been created. You can get started with services. Now you can select this. Right now, there is nothing else running in my account. So read about instances. Right now, no instances are running. Now, once this is done, it's pretty simple. Just get started, select the environment. Once you select the environment, download the SDK, and that's basically it. Then you can go ahead with creating your app engine. But again, in this particular tutorial, we are not going to look into app engine more. If you want to look into app engine, I will take this particular topic up in another video, but right now let's just follow the content. Okay, so this is done. App engine is done. We can basically delete it later if you want. Here you can see here, disable application, app ID, and paste it over here and disable it. Yeah, it's done. So this we can delete later as well. I'll just click on, I'll do this later. Yeah, so this is the app engine. Now let's start with the actual demo, which is compute engine. As I told you, there are three things we are going to do here. One is we are going to create a virtual machine. And then once we create the virtual machine, we are going to launch a web page within it. And once we launch that web page, we are going to create a copy of that virtual machine with which has a web page in it, right? So when we have that copy, we can create an instance, and we don't have to install anything. It will automatically have that web page within it because it's a copy of the already created and set up virtual machine. So now images are very useful, because once you create an image, you can use that image to create thousands of servers of the similar bandwidth, the similar RAM, the similar softwares within which has been installed in it, right? Okay, so now let's start with the first step, which is creating a virtual machine. So create instance, and over here in notifications, you can see what has happened over here. Okay, so now instance name, you can provide any instance you want. I'm going to provide it as GCP instance 1. You can add a label here. I'm going to add it as name sample, or let's say web server. Okay, so my name of the instance is GCP instance 1. I've provided that. Now I can choose my region. As I already told you guys that you can choose any region you want. But again, as we are basically doing just practice, I would suggest just go ahead with a low CO2 uh, region, because that will emit lesser carbon dioxide, right? So just choose a region which is in low CO2. So select that, and then select the zone. So once you select a zone for a virtual machine or an instance, it will be permanent, right? Region and zone for a virtual machine will be permanent. You can create a copy of the virtual machine and launch it somewhere else in some other region, but you can't move the same virtual machine to another region. You can just delete it once it's created, right? Next, over here, you can see the machine configuration, which we were reading about. So you can see now, so general purpose, E2 medium. Let me choose E2 micro, and you will see the price difference over here. You can see the total is $7.11 for the entire month. It's 2 virtual CPU plus 1 gigabyte memory. And then that's roughly $0.01 per hour. Now, let's look into memory optimized instances. This is 416 virtual CPU and 5.75 terabytes of memory. And you can see the cost over here. It is roughly $46.39 per hour. And the total monthly estimate is $33,000. $33,000. So make sure you don't spin up any expensive instances, because even though you are under a free tier eligible account, it will run out eventually. So make sure you don't spin up any expensive servers. Just stick to the basic servers for practice. If you are working with a company, select the right instance which is required for your application and choose that. Now, as I'm recording this, I would need to enable display device, because without displaying device, my screen recording would not show this particular terminal. So I'll have to enable this. So even if you're creating a video, if you're creating a screen sharing virtual machine, then make sure you enable display device, right? And then yeah, let everything be the same. Let everything be the same over here. Let it be default service account. Let it be default access. Okay. Now there is something called a firewall. A firewall is something that doesn't let things go out of the server or come into the server. For example, what exactly it does is, let's say this laptop, I set up a firewall and I don't want access from a particular website. I can set up that as a rule. Whenever a request is coming from the website, my computer's firewall will automatically block it. Similarly, I can set up a firewall rule. Let's say I can allow a particular type of traffic. I can not allow. If I don't allow that particular type of traffic, my server would not receive that. Even though that connection request has been sent, my server would not accept it. But if I allow that particular type of traffic, it will allow. Now, HTTP is for port number 80, HTTPS traffic. So these are for web pages. So these are necessary, but right now I'm not going to click this directly, allow HTTP. I will show you how to create a network firewall rule separately altogether. So for now, let's just keep like this, because if I select it right now, you won't understand one particular difference. That is, when I create this server and I install a web server in it, that particular web server will not be able to run. But once I allow the HTTP traffic, it will be able to run on the internet. Because after that, the traffic is allowed, HTTP traffic is allowed, so that the connections from the internet can access the server and the web pages delivered to you. Right? That's basically it. So now you can see your free trial credit will be used for this virtual machine instance. You're not paying anything for it. So make sure this basically shows over here. So once your free tier is done, then this won't show up. So once after 90 days, make sure you don't spin up any expensive instances, because that will come under your billing. Okay, so this is basically all the details necessary. Now you can look into advanced options. Networking tags, host name, you can provide your own details over here. For now, you can just ignore this. We'll look into networking later. Disks again, uh, there will be a small disk automatically attached to your instance, but if you want to add more disks, you can do that. For example, over here, 10 GB balanced persistent disk. A 10 gigabyte disk will automatically be attached to your instance. But if you want to increase the size of your storage in your virtual machine, then you can add a new disk, or if you already have created a disk in storage, then you can attach that as well. And security, you can keep it like that. If you want to provide SSH access, you can provide SSH access. You can create a manually generated SSH key. For example, if you have putty, you can generate an SSH key and upload it over here as an item. Over here, you can see enter public SSH key, and you can upload it over here. And then once you're logging in, you can use the SSH key to log in. So I'm not going to go into SSH again. Let's also cover this later once we come into uh, VPC part. Okay, so because right now you can access this web servers or instances over the browser itself. Okay, so now that's basically it. Now let's create the instance. Okay, I think I missed one here. Let me check if I added something over here and left it like that. Yeah, so there was this mistake. So basically, spot instances can only have this terminate instances. If you automatically have any other on-demand instances, it'll automatically get terminated. So now, basically, it's done. We've created our first virtual machine. Hope you guys are also doing this, right? So it'll take a couple minutes for it to establish its status checks, and once it's established, you will see an internal IP address, that is the private IP address, and you will see an external IP address, that is the public IP address over here. And to connect, you will get multiple options. You can connect over the browser itself. I'll be showing you how. Now over here you can see create VM instance, GCP instance 1, and its boot disk. So while you're creating a virtual machine, you're not just creating a virtual machine, you're also creating a storage disk, and that is attached to your virtual machine. right? So there are two different resources getting created right now. Now the instance got created, you have an internal IP address. So within GCP or within your network, if you want to access this particular server, this particular instance, you can use the internal IP address. If you want to access it over the internet, then you'll have to use this external IP address. So now I want to show you guys something. First, let me paste this particular IP over here. So it shows that this site can't be reached because this site doesn't exist. We just created the virtual machine, but even though this site exists, it still wouldn't run. I will show you that as well. Now, let's log in. There are two options. One is SSH. You can see SSH in browser. It directly takes you over here and logs in. Or you can connect via browser. By clicking here, you can open in browser window as well. So it's the same thing, right? Let me close this. Okay, so now our instance is open. So now we've created a virtual machine over here. We've created the instance and we've logged into the instance, right? Okay, so the first thing I want to show you guys is the present working directory. So we are in a directory under home, which is called as my username. So Kudishwaran A, this is my username, and we are within this directory. Okay, so now we can see that there are no files available over here. I can create a simple text file, and you can see a text file is created. So this is basically a Linux machine running in Google's infrastructure. It's kind of fascinating because you're able to use a server, you're able to use an instance on your laptop. You don't need any kind of processing power. You can literally run 1 terabyte RAM uh, with 200 cores of CPU on a simple laptop which doesn't have any kind of specifications, because everything is running in their infrastructure. You just need fast internet to access all of that, right? So now this is set up. So now what I wanted to show you is now the instance is running. Now let me install a web server. There is a web server called Apache 2. So let me install that. So for installing stuff, for example, let's say I'll install it like this: apt-get install. apt-get is a package manager which installs all of your softwares for you, and this is a Debian Linux. So Debian uses apt-get, or just you can use just apt for installation. But if you're using a different Linux instance, for example, a Red Hat one, then in that case, you'll have to use a different package manager called yum. Okay, so let me install this Apache 2. Okay, so now it's not able to do it because it doesn't have the permission. So now use sudo so that you get root permissions, and then Apache 2. So now it's installing, just give a yes. So now the web server is getting installed over here. So now, once the web server is installed over here, what do you think will happen here? Once I refresh, would you be able to see the web page? Just think, if you think yes or no, just keep it in your mind. Let's see what happens. So the web server is installed. Now let me refresh it. And you are able to see the web page over here because I already created a firewall rule, and that kind of added over here. Now let me show you how exactly this is working. Now over here, you can see there is something called networks. You can go to networks, or within this itself, you have an option called network interfaces, and underneath boot disk, and you have everything over here. And over here, HTTP traffic is still off. Now we can go and check the network over here. For example, let me click on network. Under network, you can see all of the default networks available. Within this particular network, we are running inside a subnet. A subnet is basically a simple sub network within an entire virtual private cloud. And over here, this is the boot disk. This is the boot disk in which our operating system is running on. Let me go back. And over here, let me go to the network interface. And here you can see there is a firewall rule established. Let's check over here. So there is something called a HTTP rule here. I created this to just check if it works. Let me delete this. Yeah, so it has been deleted. You can see delete firewall rule has been successfully done. So now if I refresh, or just let me copy this, close this, and paste it over here. Now the web page will not be visible Because my firewall does not allow HTTP traffic right now. Now, to allow HTTP traffic, what I'll have to do, I'll have to create a HTTP rule. So to create a HTTP rule, you will again have to basically create a HTTP rule over here under firewall. And here you can see there are already certain rules created. This is one rule, ICMP rule, this one rule, this is one rule. Yeah, right. So you'll have to now create a simple HTTP rule for the entire network. For this particular rule, there are 4 firewall rules. Let me go to firewall, under firewall, right? So over here, let me go back to my compute engine. Under this, you can see there are multiple options. I'm going to view network details, and over here I want to create basically a firewall option for this. I want to enable a HTTP rule for this. Yeah, so to create a firewall rule, let me open firewall in another tab. And over here, I need to create one. So under this VPC network, over here you can see add subnets, firewalls. Let's add a firewall rule over here. Add firewall rule, HTTP rule, or HTTP rule 1, because I already deleted that one. Let's assume this is a different rule. This allows HTTP traffic. And then you can select specific targets, or it can be applied to all the instances in the network. So the last time when I created a rule, I applied it to all the instances in the network. That's why when we created this new virtual machine, it automatically got applied to it. So now let me keep it again, all instances. The HTTP traffic should be accessible from across the globe, from anywhere in the internet. So for example, this particular website right now can only be accessed by like you can't access this website, but once I enable this particular firewall rule, if you run this IP address from anywhere on the globe, you can access this web page. But when you're watching this video, I would have already deleted the virtual machine, so you won't be able to see it. But just follow through with this, create the firewall rule, and basically paste your particular IP address in someone else's computer or on your phone, and check if your website is running successfully or not, right? Now, so provide this, and you can provide allow all, but I don't want to provide that. So HTTP is a TCP rule, so click on TCP, and HTTP's port number is 80, so provide 80, and then create the rule. Now we have created a firewall rule. So we've created a virtual machine, and we've created firewall rule for a website to run in it. So now once I hit enter, the web page should be visible now. So the page is visible. So now we've done the second point as well successfully. We've created a simple web page and have run it. So we have not exactly created the web page, but we've run the web server. Now let me do one thing. Let me also create a simple web page, right? So over here, you can see, okay, so I've typed this over here. So cd/var/www/html. So this is the location in which, let me clear this. So this is the location in which you will be able to see the files. Let me also do a little bit of a zoom. Yeah. So now ls. Now under HTML, you can see there is something called the index.html file. So this index.html file is what is running over here. So whenever you type this particular IP address over here, the file which is fetched is the index.html file from this particular directory. Okay. So now if I make any change to this file, it should reflect over here. Let's do that change. Okay. So let's open sudo nano index.html. Right. So now let me come down and make a simple change. So where it's written it works, I'm just gonna change updated. So it's written it works here, right? It works. I'm gonna put a hyphen but updated, right? So now Control O, enter, Control X. So I've saved the file. Okay, so you can still see index.html file is here, but now you can see it works. If I refresh this, the updated page should show up over here. So now it shows it works but updated. So you can see this web page is the one which is getting fetched. So that has been proved. So now over here, let me create another file. Let's say home.html, not so like wait 1 second, sudo nano home.html. Okay, over here I'm just gonna write hello world. I'm not gonna write proper HTML syntax because HTML can still detect basic text. So I've written that. Now you can see there are two files, but what file do you think would be visible right now if I refresh this? It will still be the same file, but it is searching within the HTML directory. So now if I do a slash and if I search for home.html over here, it should show the home.html file over here, and you can see it shows the hello world file. So we've done two things, guys. Now according to the PPT, we've created a virtual machine, we've hosted a simple web page on top of it, which is the hello world web page. Now coming to the third part, and which is basically the last part of this particular session. Now we are going to create an image of this website, of this instance, right? To create an image, just select the instance which you want to create an image for, or you can just go here, click this, and here there's an option called create new mission image. Now one more thing I just wanted to introduce is that if you want to stop the instance, you can just click on stop. It won't delete your instance, it will just stop your instances from running. So once you stop the instance from running, what exactly happens is you won't get billed for the instance, but you will get billed for the storage you're using. So make sure you don't have a lot of storage which exceeds the free tier limit. Keep it under the free tier limit, and yeah, so you can stop it and you can reset the instance if you want. And deleting the instance will completely delete all the resources related to the instance. It will delete the virtual machine itself, it will delete the storage, it will delete any web pages within the storage you have, right? Everything will get deleted. Now moving ahead, creating a new mission image. So here we are going to create a GCP one instance image, right? I'm providing the same name, just added image so that it's easier for us to track. And then you can select the source VM instance. We have only one virtual machine running, so it automatically chose that. If you have other virtual machines, you can basically come to mission images directly and select a different instance. But we just have the one virtual machine, so we already directly clicked on create a mission image of that particular virtual machine. And multi-regional and regional, if you want this particular mission image to be available only for one particular region, you can select that. If you want it to be available throughout your infrastructure on GCP, so once you create this image, you can launch this particular image anywhere, anywhere in the sense in any part of GCP global infrastructure. This particular virtual machine we created in US Central. So once you create this image, you can take this and run it in the Mumbai region as well, right? So that's basically it. You can select, you can keep everything default and click on create. Now the mission image gets created, right? It will take a little bit time for it to copy all the things from the storage and it will create this mission image. And if you go to disks, meanwhile, while it's creating, let me just introduce other things to you guys. Here you can see the disk has been created. This disk is associated with the GCP instance one. So you can basically remove this disk or clone this disk as well. But this disk is associated currently with the virtual machine instance one. If you delete the virtual machine instance one, it will automatically get deleted as well. But if you create a disk by yourself, then it won't get deleted when you delete the instance. It will still be available. You can attach it to any virtual machine you want to attach it to. That's basically it. Let's go to mission images again. Let's see if it is done. Yeah, so it's been created. Storage location is US, but it is multi-regional. That is, you can create this instance anywhere in the globe. For example, once this image is created, let me click on create instance. Over here, I want the region not to be US Central. I want to launch it, let's say, in US West 1. It's a different region, right? I want to launch it in US West 1, not in US Central. I will be able to do it. It's literally the same. You can see it's using this particular mission image. Everything, all the details which is necessary will automatically be provided by this details itself. I also want to allow HTTP traffic because it is running a web page within it, this particular web page, and then click on create. Now, there are two virtual machines getting created. This is our original one. This is the instance which is getting created because of the copy. So now this particular instance should have the same web pages as this one, but we have not manually entered anything over here. We just manually created it once and we created a copy of it. So where will this become useful? For example, let's say you're working in a company and you'll have to make a similar update in 1,000 servers and you want to launch it. For example, they are saying you to so update this particular software in the servers and then scale it up to 1,000. So what you can do is you can take up one server, install all the softwares in it, install everything necessary in it, and then take a copy of that server and then use that copy to create 1,000 servers rather than creating 1,000 servers and manually doing the tasks. Right? This is the easiest way, and this is exactly the reason why machine images are available. Um, it's created now. I'm not going to do anything. I'm just going to copy this. You can see the IP address is completely different. I'm going to copy this and paste it over here. And now you can still see it's the same web page. I've not opened it. It's just a copy of this instance which we've created. So if it is a copy, then the file which we created should also be available, right? Home.html, and it is also available over here. This is basically it, guys. We've covered three important things, that is creating virtual machine on GCE, how to host a simple web page on it. We also looked into creating an image of the virtual machine and launching it in a different region altogether. And this all happened so quickly. It's not like you're doing some heavyweight task, right? You are literally creating virtual machines on Google's infrastructure and running a website on top of it. And it seems so lightweight. That's basically the power of cloud. And this is exactly why you should also start taking cloud up. So this is basically it. This is the compute services session. Later, we'll be looking into other services. We'll be looking into storage, networking, databases, and more. Uh, so hope this is clear. If you guys have any doubts in Google Compute Engine, please leave it in the comment section. I will try to reply as many comments as possible. Also, make sure you follow this series. Make sure you subscribe to our channel and hit the bell icon so that you keep on getting updates on this particular series. Right? Okay. So hope this is clear. Let me just quickly summarize and let's get it done with. And before ending, I just wanted to show one more thing. Make sure you guys delete everything, because this is one thing people keep asking. What if I just let it run? What will happen? You will get billed, because for now, for the 90 days, the cost will get cut from your credit limit which they have provided. But make sure you delete the resources which you will never use again. For example, I'm not going to use this again, so I'm deleting it. And it's showing two boot disks also will get deleted, because these two boot disks are attached with my virtual machine instances. So now I also don't need my mission image anymore. I'm also going to delete my mission image. So now the three resources we created, I've deleted all of the resources. One more resource is basically the firewall rule, but the firewall rule doesn't cost you any money because it's just a rule. It's a logical component. It's not a physical component which costs you something. For example, storage will take up space in Google's infrastructure. Um, Virtual machines are literally running in Google's infrastructure, but when you create a firewall rule, it's just a statement on your browser, right? It's just stored in uh, the code. That's it. It doesn't matter. It doesn't take up any space in the infrastructure. So that's why you should always clear everything, delete everything, and just check once if everything is deleted, or if it's not deleting, see what's the issue with it and make sure you resolve it and delete it. So that's basically it. Now, if I refresh it, the websites will be gone because the instances are deleted. See, connection failed. The virtual machines are deleted. So if I copy this and paste it again, it wouldn't work, right? So hope this is clear, guys. Make sure you guys also create the same demo. Follow along with me and try to create the same demos. So we've covered compute services. We essentially looked into Google Compute Engine. We looked at the basics and different uh, types of mission resources, mission types. We looked into the regions and zones, and I also showed you a demo in which you can create your own virtual missions, run websites in it, and also make a copy of it, which is called a mission image. There is obviously more to it. Refer to the documentation, it has everything in detail. Again, if you are not getting any point, if you're not getting a particular concept, leave it in the comment section and I will give you an explanation to it. So thank you so much. Meet you in the next part of this particular series. Bye bye.